Okay, ladies and gentlemen, please welcome Ozhan Caravan talking about Kubernetes and CloudStack. Thank you.
Hi, hello guys. Thank you for listening to me. First of all, this is my first CloudStack event, so I'm very happy to be here. I'm using CloudStack like 8 years. First, I used it for infrastructure as a service solution. I had a public cloud company. We are just using CloudStack, and it was cool. But 4 years ago, we closed that company, and now, after that, I am more related to Kubernetes stuff. So I am an old guy who deal with lots of technologies, adventures from like Oracle DBA to latest Kubernetes thing, and also I have some developer experience journeys. So yeah, that's me. So today, what I like to show you, in generally, how we deploy Kubernetes in CloudStack in production. So there are some other ways to deploy Kubernetes in CloudStack, but what I noticed in the official documentation and advertisement, Cluster API looks like the most promising way to deploy Kubernetes on the clusters. So I'll tell you about how we achieve this approach. So first of all, what is declarative GitOps approach? So declarative means we just give you something. So you tell declarative means I need a Kubernetes cluster with version 1.28.2. I need 2 worker nodes, 3 master nodes, and for example, I need a Cluster Autoscaler there. In declarative approach, you give these details and some other bit high-level approach, then the operator or the solution that you are using will achieve a result to you and build your cluster. When you use an imperative approach, you need to give all, not all, too much detailed information. You go like how you need to build this stuff, that stuff, how you need to build your workflows, other things. So here, what I'll show you as a result, today I'll make you a live demo from my platform. So nothing is on the slides. So yeah, here, for example, in this demo, we will use ArgoCD. ArgoCD is the one of the famous Kubernetes tool that deploys applications to your clusters in a declarative way. So you link your ArgoCD solution to some Git repos, Git or GitLab repos. You tell there, for example, I need a SAP cluster deployed to this Kubernetes, or I need an Nginx server, or I need a MariaDB server, whatever. So ArgoCD directly reads that information from declarative information from there, and then executes some logics, controllers behind it, integrated with it, then builds your stuff. For example, here, in this approach, we have again ArgoCD, as I mentioned. ArgoCD is linked to the Cluster API operator. So ArgoCD monitors a GitHub repo, and when we push a cluster details, definitions over that GitHub repo, ArgoCD triggers Cluster API's operator, and then Cluster API builds our clusters under CloudStack solution. So Cluster API supports lots of different infrastructure providers. Today we use CloudStack here because it is efficient, stable, and the most promising one. So the thing is, long story short, in this demo, we just put a cluster definition into Git, ArgoCD reads it, then communicate with Cluster API operator, and then it directly provisions the cluster that we gave the definition. So how, let me give some brief information about, we are saying Cluster API, Cluster API, Cluster API, but what is Cluster API? But before going to there, so why we choose CloudStack as a Cluster API on-prem provider? First of all, the company that I gave support, we use Kubernetes clusters with Cluster API, but they are all generally on AWS or other cloud providers. So we are heavily using Cluster API. But when we decided, hey, we need a on-premise solution, which we could build up some Kubernetes clusters there, then we checked that Cluster API has like maybe 20 or 30 cloud and on-premise and other edge solutions providers. Which one we need to use? First, for example, we check VMware. For example, for VMware, Cluster API directly their main ship to deploy Kubernetes clusters. So they are heavily involved in the Cluster API ecosystem. So they deliver Kubernetes clusters on using Cluster API. But the problem is you need to have a vCenter license, other things, lots of nodes. So to test or going forward, it is not easy. Then I checked OpenStack. How I check? I check the documentation. Then I go to Slack group and I ask the guy, hey, what is the easiest way to spin up something like CloudStack or OpenStack there? And the guys responded me, for OpenStack, you need a working OpenStack, fully OpenStack things with Neutron, Nova. And but if you like to test something, you need to use DevStack. But to spin up a DevStack, it is even not production ready. It is like you need to spend 30, 40 minutes, depends on your hardware, lots of stuff. So it's really complex, and no one showed me a simple solution, like deploy something there, and it is ready, and over that you could deploy your Cluster API solution. And again, we passed this setup because it's very complex. It's very hard to implement it. Even I am OpenStack certified engineer. I hate OpenStack. Also, other thing, there is a new approach, Sidero Labs, Talos Linux. They are very good. They have their own Linux operating systems. It is not, they take all unnecessary stuff from the Linux operating system. They put an API over there. For example, if you need to deploy, create a user in their Linux server, you just talk with their API, send a request, the user automatically created on all the related servers or whatever. But the thing is, we need Ubuntu Debian there. So again, we skip this solution. Then I said myself, hey, I know this CloudStack from 8 years, and I'm still using it. So why we gonna try? I checked the open source group about the Cluster API, because in Cluster API, there are lots of infrastructure providers, and they are privately maintained. Privately means individuals maintain it. It's an open source individual projects. Of course, there is a one Cluster API core solution, but it works with infrastructure providers. And I checked the Cluster API solution, CloudStack solution, and I noticed that there is a contributions there. It is active, and also I find a video on the internet, and it is really it just the the video directly expresses how it works. So it is really good. So it's a good starting point. So we decided to continue with CloudStack. So for Cluster API, how it works, let me give you again a brief information. So there is an infrastructure provider, bootstrap provider, and control plane provider. There are some components like this. Infrastructure provider is responsible to deploy your infrastructure. In our case, maybe it's a network, maybe it's an SSH key, maybe it is an VM, maybe it is some other things. So everything needs to be done from infrastructure way, needs to be handled by this provider. Here we use CloudStack for this part. Also other providers, like we have a bootstrap provider and control plane provider. You know, if you need to build a Kubernetes cluster, building a Kubernetes cluster is very easy. You need 4 components. One of them is kubeadm, and then kubeadm, kubectl, and there is a CNI packages. You just deploy the packages, And then when you execute some kubeadm commands with some parameters, it directly builds up a Kubernetes cluster. So building Kubernetes cluster is not a hard thing. But here, bootstrap providers and control plane providers' mission is convert these Kubernetes related, for example, we need to install a package. So how we install a package, we need to convert this package installation to a Cloudinit script, because how AWS, CloudStack, and other guys are working. So Bootstrap provider is responsible to convert these installation packages, configuring packages, and other things to bootstrap the Kubernetes cluster. Also for the control plane provider is again configures your API server, controller manager. I mean, it controls all the life cycle of the Kubernetes cluster. So, how Cluster API works, let me give some general more info. You give a declarative cluster information, then, you tell Cluster API, hey, I need this spec in a declarative way, I need this spec cluster, and then it needs your spec. It says, okay, this guy needs this image. He needs to use this SSH key. Okay, we need to use this compute offering. We need to use these security groups. We need to do this firewall scripts. Converts everything to Cloudinit scripts. Then communicates with the infrastructure provider. Here it is CloudStack, and then CloudStack spins up the server with the Cloudinit data that this provider generated, and then everything is there. kubeadm starts from Kubernetes way, and then kubeadm builds up the cluster with the nodes. Then you will have you just have an working Kubernetes cluster. Then it adds worker nodes, and then everything is completed. Also, this is not the limit of the Cluster API. For example, it controls all your life cycle of the cluster. So if you like to upgrade your Kubernetes cluster from 127 to 128, Cluster API seamlessly, without any touching from the operators or other person, it directly makes the upgrades of the cluster. So you just build it, and then you just communicate with Cluster API. Okay, you gave me cluster, now upgrade it to this version. It upgrades it. Or for example, when the workloads, when we have more pods and working things on the Kubernetes cluster, for example, 2 nodes are not enough, then it adds more nodes. So it directly supports also Cluster Autoscaler. So from building to managing, all life cycle management done here. So, this is like a mixture of lots of components. There are some things that there are some operators in it. It is not open source. Me and my friends wrote it. But generally, what technologies use it in this demo? We are driving everything from Gitlab CI. We are using ArgoCD because, as I mentioned, ArgoCD directly tracks a Git repo, and then when it sees a cluster definition, it communicates with the Cluster API. Cluster API communicates with CloudStack to provision the clusters. So the first thing is, if we need to provision a Kubernetes cluster, first we need a fully operational image. That's the first thing. First, I'll show you the diagram, then I'll show you how it works. So there is a project called Image Builder. Image Builder's responsibility is it just builds QCOD2 images for Ubuntu, CentOS, Red Hat, whatever you are using on your cloud. It just builds your QCOD2 image, which it has related Kubernetes packages. As I mentioned before, to run a Kubernetes cluster, you need kubelet, kubeadm, and some other tools. So we are using image builder project, but the thing is, we like to be flexible. So image builder project only builds images for 3 or 4 Kubernetes versions. So we wrote a wrapper over there. Every night there is a GitLab CI job, scheduled job. It just checks for GitHub's Kubernetes releases API. I mean, it just takes the Kubernetes releases versions. For example, every night it runs, it says, hey, today 128 for released, and it communicates with the Cloudstack. It queries the templates that are registered there, and it says, hey, this release is not there. Then it makes some changes on the image builder project, and it builds the version it builds the new Kubernetes version release. So by using this technique, we have every Kubernetes releases version ready on our CloudStack repo. So everything is ready. If developer A comes, if developer A needs, and I need a Kubernetes version with 1.25.10, whatever, it is there. So we just tell him, hey, the release is there, just check it out. So everything is ready. So we just, as I mentioned, we just write a scheduler job. It just builds the required QCO2 images for Kubernetes and Cluster API. So this is the other one. So this is a little bit complex, but when you see the demo, you will understand easily. So we are here, we have ArgoCD program, and ArgoCD has 2 application sets defined over that. One of the application sets directly checks for, on ArgoCD, we have applications. Applications are like, we could think that it's an Nginx application, or it may be a cluster. We need a cluster called C. It's a cluster C. It's an application. So every entity that we deploy over the Kubernetes cluster is an application. So application set directly monitors a directory on the GitHub repo, and when on that path, if there is a YAML comes, it directly reads, and it reads that YAML, converts to application, and deploys it to Kubernetes cluster. So let me show you from a demo. It will be easier to understand. I don't know how many people use ArgoCD, so it will be easier. For example, so this is an ArgoCD deployment. So here, it is working on the Kubernetes cluster. You need to build up a Kubernetes cluster. Then you integrate your ArgoCD cluster over there. And then you connect some clusters directly to this cluster. For example, right now, there is U1 and S1 clusters are connected to this cluster. For example, S1 comes from storage. So if I check, for example, rook-sep, we deploy directly rook-sep storage to S1 cluster using those 2 applications. For example, when you check the Helm chart, when you check the application, you could see all components below that application all components are directly deployed to S1 cluster using this application. So all the rooks, these definitions, pod definitions, steps, all secrets, whatever, everything is here. So if I need to deploy Nginx, I just make the definition on the Git repo. Let me show you the Git repo. For example, here, there are applications here. For example, this is S1 cluster. For example, this is the cluster definition. I just say, just deploy Cilium CNI over this cluster, Metal LB over this cluster, Ingress, and rook-sep, and GitLab runner to this cluster, then it deploys it. So let's come to the, where is it? let me show you how we deploy a cluster. So there is an application set defined in this ArgoCD, and it directly follows this capc folder. Right now, it is empty. When we check our Kubernetes cluster, for example, this is my Kubernetes cluster, k-get clusters -a. There is no cluster. Let me connect to CloudStack to show how CloudStack is looking. So as you see from here, only 2 deployed Ubuntu or Debian instances here. So there is no cluster, only 2 VMs. And of course, there are lots of images under that. So you see, I have Debian for all Kubernetes versions. For example, 1.28.4 is released maybe this week or last week. It is directly here. If anyone needs this version, I could directly spin it up. So how we deploy a cluster? Let me show you. So I will just push a definition. So this is my cluster definition. As you see from here, I just define 43 lines, and they are very easy definitions. I mean, I need a cluster. When I read this file, I need a cluster with 126.4. Its domain name is this one. Let's use this SSH key from CloudStack's perspective. And I need a Kubernetes API server, which has an endpoint in this IP and port number. I have this failure domains here. By the way, I am using guest networking here. I don't use CloudStack's VPC and other networks because I don't need them. I need to access Kubernetes clusters from outside. So I don't need a demilitarized zone, a VPC or other things, but they are also working. But in this in this demo, I am using shared networking, which is named like this. Also, in this cluster, I want Autoscaler to be enabled. So Autoscaler is minimum 1, maximum 5. This means that it will spin up this cluster with minimum 1 worker node, and if there is a load on the cluster, it will spin up the cluster nodes to 5. So also here, you see those are the service offerings. So this is a simple service offering. I am using 4 cores, 4 gigabytes, and 30 gigabytes for the control plane node, which is using on the backend as SEP, RBD storage. And so those are the same. Also, I have an in-house built operator, which handles some other tasks. It is also, I also enabled that. So here, so you see this folder is empty. I just copy that folder. I just copy that file to that folder, and then I will sit over there. To make it easy, I just use VS Code, enable capc1 cluster. Think about, you have a developer just push this file to your directory. And then, okay, so the file is here, and then ArgoCD is monitoring that folders. So it directly noticed that there is a webhook which I'm using. It directly noticed, hey, there is a new cluster definition came. So it starts to build the cluster. So you see, it starts to deploy machine sets, machines, kubeadm configs. Those are the configs that Cloud Init is using. For example, let's come to CloudStack and let's check what's going on there. So in a minute or less or more, it will start to spin up the clusters here. So first it deploys everything. So if it is imperative way, you need to define everything from the scratch with more definitions. But because this is a declarative way, I just sit and check my browser. So when I check first node is not came. This is the control plane node. In Kubernetes, everything is controlled by the control plane nodes. Control plane nodes are managing all the Kubernetes clusters with worker nodes, but this is the brain of the cluster. Everything is handled with this control plane. So if we check it is, for example, console. I think it is blocked here, or maybe it's using a special port. I don't know. This Wi-Fi doesn't let me in. So it is deploying the first control plane node. Also, when we check inside the Kubernetes, let's check. So you see cluster and all it is sub-child resources are directly coming up. Cluster state is not in ready state. It will just wait for a moment. For example, let's check. So you see control plane node now ready. We have built our Kubernetes cluster and we have our worker nodes. So worker nodes starts to come. So it is running, it is up. So here, if you check, cluster becomes ready. So this means that I could connect to the cluster. Let's connect to the cluster. First, we need to, in Kubernetes, we need to download, it is kubeconfig. But maybe I'm in the wrong cluster. Okay. So now I am connecting to the cluster, which is named capc1, export kubeconfig. Let's not change it, this one. So now I am connected to the cluster that we already spun up, but it didn't come yet. Strange. Let me check. No, IP is correct. kubectx. Yeah, I'm incorrect. Whatever, I think Demogas is following us. So the cluster is spinned up. So if you check from ArgoCD's interface, it is healthy. All it is nodes, everything is there. So it is. So we already got the cluster, but I don't know why I couldn't connect to it, but it's no problem. So if I could connect to it, maybe it is blocked from the firewall here. I never tried with the 6443. Maybe I'm using this guy's firewall, Wi-Fi. So maybe it is blocked because of there. So as you see, I could directly spin up a cluster without giving any too much detail on it. So it is already there. Also, because I couldn't connect to it, but it doesn't matter. Also, right now, Cluster Autoscaler is activated. So if I could connect to it, I could just build some dummy resources. And on the CloudStack side, I'll see that new nodes are coming here. Yeah, that's the story here. So thanks for listening. If you have any questions.
Thank you, Ozhan.
Thank you.
Any questions from the room for Ozhan? Rohit.
Ozhan, lovely demo and love to see the talk and how you're using CAPC. What kind of scale and application do you run on these clusters? If you can talk a bit about your use case and how you're benefiting from all of this.
In Kubernetes, Cluster Autoscale works in a different way. on our, for example, when we use our CloudStack, we just monitor the CPU or memory usage, and then we add a new node. But on Cluster Autoscaler, it just checks if there is an unscheduled pod there, it adds a new node. So it is not, I don't kill the cluster with a big CPU memory utilized workload. I just spin up something. For example, I spin up 5 pods and I tell the guys that, hey, use pod and affinity. This means that every pod there needs to work on different nodes. They couldn't stay on the same node. And this means that, for example, here I have a 1 node. I will have 4 unscheduled pods. And this means that Cluster Autoscaler will spin up 4 new nodes for me. So from your question, also the other thing, if you like your cluster to scale up with the CPU and memory requirements, you need to set your requests and limits on the Kubernetes in a correct way that kube scheduler is aware. Then it says, for example, you have 4 applications and 4 core CPU. And then you have 5 applications now, and it needs 1 CPU, but kube scheduler say, hey, this node's all CPUs are occupied. Give me a new node. Then Cluster Autoscaler directly gives a new node. By the way, one more thing I forgot to mention. In my test, Cloudstack CAPC provider spins up new node in like 90 seconds. So it's a very, so it spins up a new node and it joins to the Kubernetes clusters on only 90 seconds. It doesn't take more. Also, it is like this is my lab environment, but yeah, it's just very good result on Cloudstack.
Thank you, Ozhan. That is all we've got time for, so please, one more time. Thank you, Ozhan.
Cheers, thank you.